This is the teaching vault, the part of Nodus built for the person who has to prepare the class, not study for it. One workspace holds the course, the class lists, the materials, the assessment and the planning, and all of it stays on this computer. The sidebar follows the shape of the work: organize, analyze, assess, and create. Everything hangs from an academic year. It is not a label, it is the scope that decides which courses, which timetable, and which gradebook you are looking at. This selector switches between years and the whole section follows it. Years are managed in one place, each with its own dates, so last year stays intact instead of being overwritten. A new year starts empty, and the previous one is still there, which is what makes a course reusable rather than disposable. Inside the year sits the course, and inside the course, the subjects you teach. This teacher has 3 contemporary history subjects. We will add the 4th now. A subject is created from the header, with a color and an emoji that will follow it into the timetable and the calendar. 4 subjects, all inside the same academic year. Within a subject, you can group work into folders and topics. Here, the unit on the Industrial Revolution that the rest of this video is about. Groups are the class lists. Who is in which class, in which subject, in which year. Creating one asks for the subject, the year, and how many students to expect. That number pre-creates the rows, so a register can be typed straight down the list instead of one student at a time. Here is a class of 12. Every name in this video is invented. No real student appears anywhere in it. Beside each name sits an identifier. That code, not the name, is what any part of Nodus uses when it has to refer to a student. And the vault says so where the data lives. No AI feature in Nodus grades, profiles, or assesses a student. We will come back to exactly how that is enforced. A second group for another subject can be started by importing the list from the first, rather than typing it twice. The timetable is a grid of days and time slots, and it belongs to the academic year like everything else. Slots are yours to define. Add a morning or an afternoon one and set its hours. The next one starts where the last finished. To put a class on the timetable, click an empty cell. Choose a subject, and it takes the color and the emoji you gave it, so the week is readable at a glance. Saved. The subject is now on Tuesday morning. Not everything in a week is a subject, so a cell can hold a freestanding activity instead: office hours, a meeting, a seminar. And when the year turns, the whole grid can be copied into the next one and adjusted, rather than rebuilt. Beside the timetable, the calendar holds the things that happen once: a seminar, a deadline, an exam, each able to remind you. Materials are the sources you teach from. These 5 are the reading for the unit. They come in from the device or straight from Zotero, and each one is filed under a subject, a folder, and a topic. Opening one shows the document itself, annotatable, with the notes you have linked to it. On import, Nodus reads each source. It extracts the text, indexes it for search, and then asks a model to draw out the ideas it contains. What comes back is not a summary. It is a set of ideas, each tied to the passage that supports it and the relations between them. Those ideas land here, 105 of them, from 5 sources, all belonging to this subject. Each card carries what kind of thing it is: a construct, a finding, a method, and the claim itself in one sentence. Open one, and you get the evidence, which source it came from, and the passage it was drawn from, so nothing has to be taken on trust. The same network, drawn. Every node is an idea, and every line is a relation, the model found between 2 of them. The contradictions are worth looking for on purpose. Where 2 of your own sources disagree is usually where the lesson is. Classes can be recorded, either by uploading audio or by recording the session in Nodus itself. Here is a seminar recording, waiting to be transcribed. The transcription runs on this machine with a local model, so the audio of a class never leaves it. The result is aligned to the audio. Click Align, and the player jumps to it. From there, a transcript can become class notes, filed in the same subject as everything else. The chat answers from your materials and nothing else. A teacher asks it different things from a student. Not explain this to me, but what should I do with this in class? It finds the disagreement between two of the sources and says which two, because the answer carries its citations back to the originals. And the scope is yours, the whole library, or a selection you make. Assessment starts with the question bank, a store of questions that outlives any single exam. These 12 were written from the unit's own materials, each one keeping the source it came from. Generating more takes the sources you choose, the difficulty, and the kind of thinking you want to test. A rubric is the other half of the assessment. Criteria down the side, levels across the top, and a descriptor in every cell. This one assesses a commentary on a historical source over 4 criteria and 4 levels. Criteria can be weighted, so contextualizing a source counts for more than the tidiness of the prose. Any single descriptor can be written by the model, and it is given the rest of the table, because what makes a descriptor good is being parallel to its neighbors. Nodus then reviews the rubric against what makes rubrics work. Observable behavior, 1 aspect per criterion, no vague praise. And it prints, so the students can be given the thing they are being marked against. Exams are built question by question and come out as a printable paper. The editor is on the left and the paper on the right, updating as you type. The header carries the institution, the subject, the group, and the duration, and up to 2 logos. There are 13 question types, from a definition to a case study, and each brings the right amount of answer space with it. We will add an image commentary, the one type where you supply the picture. This is a print of the Leader of the Luddites, published in 1812, and the students are asked to read it as a source. A section statement carries a shared text with its own sub-questions, so the paper numbers them 2.1 and 2.2. Exporting gives the paper with an answer key, or the key alone. And this is what comes out: the logos, the header, the marks beside each question, and room to answer. The gradebook follows the assessment plan of your own course guide, rather than a scheme somebody else chose. This one weights the written test at 60%, the source commentary at 25%, and seminar participation at 15%. The exam columns were not typed. Adding an exam to a plan creates 1 column per question, each worth what that question is worth. The commentary column is marked with the rubric itself. You pick a level per criterion and the mark follows. A cell can also carry a status instead of a value: not submitted, not yet assessed, exempt, or validated from a previous year. The final column is computed from all of it. This class averages 6.3, from 3.5 to 9.1, with 2 failing. Any mark can be opened up to show exactly how it was reached, which is what you need when a student asks. The analysis looks at the questions rather than the students, which ones discriminated, and which everybody got right. And the official record exports as PDF, Word, or a spreadsheet. Which brings us to the question a teacher should ask before putting a class list into any software at all: what happens to it? First, the plainest part. Nothing here computes a grade with a model. The gradebook is arithmetic, done on this machine, and the record you export is a local document. Second, the AI features work on your materials, never on your class. The exam, the rubric, the question bank, the chat, and the unit are all built from the sources you indexed. Third, every student carries a stored identifier like this one. It is random rather than sequential. Numbering them 1 to 30 would leak how many there are, and since lists are alphabetical, roughly who is who. The alphabet leaves out the characters people misread. No letter O, no digit 0, no 1, and no lowercase l, because a teacher reads these aloud and types them back. And when text does have to reach a model, the names are swapped for those codes on the way out, and swapped back on the way in, so you never see the machinery. It refuses to guess. If a name could belong to 2 students, it is left exactly as written, and you are told, because attributing one student's work to another is worse than not substituting at all. Before anything is sent, the outgoing text is reread, looking for names that should have gone. If one is found, the request is not sent. Images are refused outright while this is on, because a name handwritten on a scanned exam is not something a text substitution can remove. And where an outside model can read the gradebook at all, through the connector, the columns holding names are dropped by construction. It hands over codes and marks, and nothing else. The last section turns all of it back into teaching. Unit design writes a unit from your own materials for the person who has to deliver it. It runs as a queue, so you set one going and carry on working. First, the objective, what the unit is about, and who it is for. Then the structure. You can let it group the materials and propose the parts, or you can decide them yourself. We will decide 4 parts in this order. Each part takes a title and, if you want, a note about what it should concentrate on, a source to lean on, and this conception to face early. Then the length, the language, and the model that will write it. A cover image can be generated with it, in a style you choose. Then it goes into the queue to be written in the background while you carry on working. Here's the unit in the 4 parts that were asked for and in that order. It is written to the teacher, not to the learner. What to present in what order, which misconceptions to expect, and an activity to check understanding. Every claim cites the material it came from, and the citations open the source. And the cover image generated after the text was safely saved. A course, a class, a timetable, the sources you teach from, the ideas inside them, an exam, a rubric, a gradebook, and a unit. In one place, on one computer. That is the teaching vault.